All right, good evening. Thank you all for being here tonight and to hear about and discuss an interesting issue that connects three academic fields, mathematics, economics, and political science. It's wonderful to see really such a great turnout and also some new faces. You still have your music on. I was like, okay. And so we will hear about a talk entitled Matters of State, the Mathematics of Power in the Electoral College by Professor Stephen Szydlik from the University of Wisconsin-Oshkosh. I am Henrik Schatzinger, co-director of the Center for Politics and the People, along with my colleague, Professor Brian Smith. I would also like to welcome our viewers via our Ripon College Live Events YouTube channel. Professor Szydlik has taught at UW-Oshkosh for 21 years and received a Distinguished Teaching Award in 2011. He's an accomplished scholar who earned his doctorate in mathematics at UW-Madison, studying hyperplane arrangements. With regard to his research emphasis, let me quote him directly. Although I still like to think about abstract mathematical problems, I especially enjoy exploring topics that I can share with a broad audience. My recent research has focused on mathematics education, especially student beliefs about the nature of mathematics and on applications of mathematics to the sport of cross-country running. In 2009, one of Professor Szydlik's classroom activities became a cover article for the Mathematics Teacher Journal, and another article was an Editor's Choice article in Teaching Mathematics and its Applications in 2013. He and a colleague also present a Jeopardy-style mathematics game show for undergraduates twice a year since 2006 in various locations around Wisconsin. He has also a passion for distance running, and for many years he was a competitive ultra marathoner. After the talk, we will have time for questions from you, the audience. Please join me in welcoming Professor Steve Szydlik. Yeah, there is one echo. I don't know. It bothers me to figure out how to talk.
Do you need it?
Yeah, it's because of YouTube.
Got it. Okay. So thank you so much for the introduction, Henrik. Thank you so much to Ripon College for the invitation, especially to the Center for Politics and the People, and Mackenzie Lamb in the Mathematics Department. So I want to welcome you and thank you all for coming. And I, especially as Henrik said, I'd like to speak about mathematics to a broad audience. So the talk has mathematics in it, but if you're not a mathematics expert, that's okay. My goal is to make it generally understandable. Okay, and I thought I'd start with a problem. My wife is not here. If she was, she would know better than anybody that my own personal wardrobe is kind of limited. Okay, so as it turns out, I actually have exactly 3 pairs of pants and 5 different shirts. And when I get dressed in the morning, I don't really pay attention to trying to mix and to match. And so I'm happy to mix them up any way. So even if you're not a math person, the question, or even if you are a math person, then a question that it's going to kind of come up in the talk would be, how many different ways do I have of picking an outfit? How many different outfits do I have? 3 pairs of pants and 5 shirts. You don't have to answer. Just get that problem kind of running in the back of your head, because it'll come up in the talk. Okay? All right. All right, so here are the goals for today. The number one goal is I want to get a better understanding of which states have the most power in the Electoral College and why. Okay, and then also how much our individual vote matters and how this differs from state to state. So those 2 questions are actually a little bit different, so we'll talk about the distinction between those two questions as we go along. In my day job, I am a mathematician. So the way pure mathematicians operate is we make assumptions, and then we follow those assumptions to their logical conclusions. Okay, so I'm coming at this from the standpoint of a pure mathematician, and so our approach will be theoretical. The assumptions that I'm going to make are sort of twofold. One is that to make our life easy, we're just going to deal with two candidate elections. A and B, candidates A and B, not multi-candidate. And the other assumption that I'm going to make is that all the states are toss-ups, that we're not sure how they're going to vote. Okay, and those can be, you can think of either of those as being sort of questionable assumptions, and at the end of the talk we can discuss, how we can push things to answer the more general questions. Okay. All right, so first thing we have to talk about is the Electoral College, just sort of as a reminder. And I'm not sure about you guys, but the way lots of us learned about the Electoral College, it's the same way that we learned about lots of historical and grammatical and mathematical concepts. If you're the right age, then you know what I'm talking about. Schoolhouse Rock? Right. So Schoolhouse Rock actually did do a video in 2002 called "I'm going to Send Your Vote to College" as a way to explain the Electoral College. And I'll show you a little clip. The whole spot is about 3 minutes and 15 seconds long. And if you have, there's the link. If you have 3 minutes and 15 seconds, I strongly recommend that you spend it somewhere else. It's not at the top of the Schoolhouse Rock oeuvre. I guess I would say that of the 3 minutes, maybe about 80% of it is puns on "we're not really going to college." Using that, I'd say about 10% is explaining the Electoral College. 5% is insulting mathematicians, and there's 5% is actually a misconception about the Electoral College. But I'll just let me just play just a real brief clip. Sorry. Need the wireless.
I'm gonna send your vote to college when you vote for president. And if you'll let me share some knowledge, you'll understand this big event.
All right. So that's just a little bit of I'm going to send your vote to college. As I said, if you have an opportunity to watch Conjunction Junction or Nouns of Person, Place, or Thing, those are great. This not so much. All right, so we have to look to a more standard reference if we want to understand the Electoral College, right? And so here's just a very brief outline of how the Electoral College works. Of course, a lot of you are very familiar with this, right? Every state has electors, right? And the number of electors for the state is equal to the sum of the number of senators and congressmen. And we know that every state has exactly 2 senators, but then the congressmen are allotted roughly proportionally, right? Small states get just a few congressmen, large states get lots of congressmen, but every state gets 2 U.S. senators. So the number of electoral votes or electors that a state gets is roughly proportional, but not quite. Okay. All right. So a state can select the electors in any way that it decides, and that's a little bit of a misconception, right? So a state can do it any way it wants. Most states do decide to award their electors all or nothing. So if President Barack Obama won Wisconsin in 2012 by just a few percentage points, but all of Wisconsin's electors were cast for Barack Obama. 2 states actually choose not to do that, Maine and Nebraska, and they divide their electoral votes up by district. Okay. The candidate who receives the majority of the electoral votes is declared the president. Right? And if no candidate gets a majority during the casting of electoral votes, then it goes to the House of Representatives, where all kinds of craziness can ensue. Right? And that's happened once in our country's history in 1824. We've been close a couple other times, but it just happened once. Right? So the Constitution, Article 1, outlines the procedure in detail, and Article 12, the 12th Amendment, the 12th Amendment of the Constitution cleans some problems up that they encountered. So you can get more details there. All right, so the Electoral College is a little hard to get our head around. there's 50 states plus the District of Columbia, right? So 51 players in the Electoral College system. It's hard to get our head around it. So I've got an example of a sort of a smaller country. It's a country that's holding a presidential election, and they have a problem in the country with a high crime rate. In fact, the murder rate is skyrocketing. So these two candidates for president, we have Colonel Mustard, who promises he's going to make the military strong, and then we have Professor Plum, who's going to be the education president. All right, and we have Colonel Mustard and Professor Plum. And so I thought I'd start, this is what your votes are for. You're voting for either Colonel Mustard or Professor Plum, all right? And so first I want to see who wins the popular vote. Okay, so if you're a Mustard person, raise your hand. Okay, so if you look around, it looks pretty strong that Mustard's going to win. How about Plum? Okay, it's reasonably close, but Colonel Mustard, I think, pretty clearly wins the popular vote. Okay, except we're not doing this by a popular vote. We're going to do an electoral vote, use an electoral college. So let's pretend in our country that there are 4 states of different sizes, and so they have different numbers of electoral votes, roughly based on population. Okay. So let's say we have Anderson, Brockway, Carnegie, and Doling. I don't know if I got that name pronounced it right. All right, so Anderson has 5 electoral votes. Okay, you guys in Anderson are the back 3 rows. Okay, all right, you guys. Oh, by the way, if you didn't get a vote, I apologize. I did not get a chance to see your ID when you came in, and so you're disenfranchised. Okay, so you guys in the back, Anderson, my state of Anderson, the last 3 rows, how many of you vote for Mustard? Okay, and how many of you for Plum? Okay, again, that's fairly close, but I'm going to go with Mustard for the back 3 rows. Okay, and we're going to do an all or nothing, so all these 5 electoral votes go to Colonel Mustard. Okay, let's see, so then this row here, let's see, plus you guys in front here. Oh no, sorry. Row 2. Row 2, you guys are Brockway with 3 electoral votes. Okay? Row 2, how many of you vote for Mustard? Okay? And how many of you vote for Plum? All right? Close, but I'm going to go Plum on that. Okay? So that's 3 votes in Plum's column. All right, and now we're in the front row for 2 small states. We have Carnegie, and that's you guys. All right, so you guys here. How many of you vote for Mustard? Okay, we got 2. How many of you vote for Plum? Okay, we got 4. All right, so that's a win for Plum. And then you guys at the end here. How many of you vote for Mustard? All right, and how many for Plum? Okay, so that one goes to Plum. All right, so the winner in our Electoral College is Plum. Right, okay, 6-5. All right, completely legitimate election, right? One of the points I'm trying to illustrate is that it is possible to win a popular vote and lose in the Electoral College, right? Those can give you different outcomes. All right, and that has happened. We know that's happened a couple of times in our country's history, most recently in 2000. Okay, so we're going to hang on to this example and work with it. It's going to be our example to work with a small, understandable example along the way. Okay, so in the big world, in the real world, right, we have these 51 states ranging from big California to Wyoming small. Of course, California has the largest population, so it has 53 representatives, 55 electoral votes. Wisconsin's a moderately sized state, 8 representatives and 10 electoral votes. And Wyoming, very small, but the Constitution guarantees every state at least 1 representative, so every state gets at least 3 electoral votes. Okay, so there's 538 total electoral votes, and we need a majority to win the presidency. So the quota so we'll use that word quota, is 270. So I know if you follow the news, you hear things talking about things like the road to 270 and getting to that 270 number. All right. Okay, so why do we have an electoral college? The political science majors and faculty can know a lot more about this than I do, but fundamentally it comes from our founding fathers, right? When they wrote the Constitution, there was a strong tension between the sides of direct democracy, so the people choose, versus a representative government, right? So we'll have people with some experience making the decisions. Right? So some of the founding fathers thought that the Congress should elect the president, and some people thought that the people should directly elect the president. And the Electoral College was sort of a middle ground, right? So the people choose the electors, and then the electors choose the president. And I love this quote from Alexander Hamilton in the Federalist Papers, so I want to read it. He says, the process of election, that is the Electoral College, it affords a moral certainty that the office of president will never fall to the lot of any man who's not in an eminent degree endowed with the requisite qualifications. Talents for low intrigue and the little arts of popularity may alone suffice to elevate a man to the first honors in a single state, but it will require other talents and a different kind of merit to establish him in the esteem and confidence of the whole Union, or of so considerable a portion of it as would be necessary to make him a successful candidate for the distinguished office of President of the United States. Wow. Right? So he's arguing that the Electoral College serves as a check, right, to make sure that an unqualified person is not elected president. Not that that could ever happen. All right. So let's talk power. So who has the power in the Electoral College? The simplest answer, of course, is it's the big states, right? Larger states have more votes in the Electoral College, and so they have the most power. All right, that's pretty blunt. A slightly more nuanced view is that there's a bias towards the small states, right? And I'm sure a lot of you have heard this argument before, right? California, if we take the number of people in California, divide by the number of electoral votes, it's about 680,000 people per electoral vote. All right. On the other hand, on the other extreme, if we take Wyoming's population and divide by their 3 electoral votes, it comes out to about 190,000 people for every electoral vote. And again, Wisconsin's kind of in the middle there. Okay, so a voter in Wyoming, in some sense, has about 3.6 times the power of a voter in California. All right. So that's an argument about inequity in the Electoral College. Now, I want to be careful. So as I said, I'm a mathematician, and so I traffic in logic and making arguments. But the currency of mathematics is precise language, and so I want to be really careful about what I mean when I use that word power. Okay, and so. I want to make a couple of distinctions. First of all, I want to make a distinction between the power of a state in the Electoral College and then the power of an individual. So thinking of those as two different things. And I want to talk about the power of a state first. Okay? And then when I talk about power, I want to measure it in a very specific way, a very precise way, by thinking about how often a state matters. How often does a state make a difference in an election? Okay, and then I'll measure the power among the states sort of relatively. All right. So let's go back to our example to kind of get our head around this. I'll call the country Utopia. All right. So here's one way you can do it. It's a process called finding the Banzhaf power index. Okay, so if you want to find out how much power an individual state has, one way you can do it is you can figure out all the different ways that the states could band together to form winning coalitions, and then in each of those winning coalitions, figure out who matters. Okay, so the notation I'm using up there on the top, maybe you kind of understand it. The 6 is how many votes it takes to win in Utopia, to win in the Electoral College. And then the 5, 3, 2, 1, those are the individual votes for the different states, A, B, C, and D. Okay, so can you tell me one way that, that two or more states could band together to form a winning coalition? Just shout it out.
First and last.
First and last, so A and D could get together. Sure, another one.
First and second.
First and second, A and B could get together, right? A and B together have 8 votes, and so that's enough to win. What are some others?
BCD.
BCD, that's the experience we had here, right? Okay. There's a lot of ways you can do it. Let's just run them down. Okay, so A and B could get together. A and C could get together. The first and the last, A and D, and then we can do triples, right? So A, B, and C, those together win. A, B, and D together win. A, C, and D together win. B, C, and D together win. And there's one more. All of them, right? The Grand Coalition.
Yeah.
Okay, so that's a list of all the ways that the states could get together. If A and B cast their vote together for Colonel Mustard, their electoral votes, then Colonel Mustard will be elected. Okay, now let's count or find which states are important, which states are critical in these winning coalitions. Right? They don't all matter in every coalition. Can you see that? So, like in that first one, A, B, who matters? Do they both matter? Yes, right? If either of them drops out, you no longer have the 6, right? So we would say that A and B are both critical in that winning coalition. How about an AC? Both of them matter, right? In AD, they both matter. How about an ABC? A matters, right? If A drops out, then you've only got B and C, and then together you have 5 votes. All right. Does B matter? Is B critical? So if I drop out B, so take B out, how many votes do we have left? 6. We still make it, right? So B is not critical in that winning coalition. How about C? C is not critical. So take them out one by one, and you can see that A matters, but B and C don't. So we would say that that A is critical in that winning coalition. Okay. All right. How about in ABD? Who's critical? Just A, right? In ACD? Just A. How about in BCD? They all matter, right? And what about in ABCD? None of them matter, right? You can drop out any one of the states individually, and it will still be a winning coalition. Okay? So that's a way we can measure how a state matters, right? And then power is it's sort of a natural process now, right? We can count how many times each player or state is critical, right? So A is critical 6 times. B is critical twice. C is critical twice. D is critical twice. Okay? And so in some sense, A matters 3 times more than B or C or D. Right? And so A, in some sense, has 3 times the power of B and C and D. And you can put a percent on this if you want, right? In sort of a natural way. And that's what we call the Bonds-Off Power Index. So count the number of times a state is critical, and then divide by the total number of critical occurrences, and that gives you the gives you what we call the Bonds-Off Power Index. All right. So there's 12 critical occurrences altogether, and so A has 6 of those, so A has about 50% of the power, and then B and C and D each have 1/6 of the power. Okay. All right. So that's how we can measure power. At least one way to measure power. There are other ways as well. All right. Big lesson here, right? It's maybe our first big lesson is that the voting weight doesn't tell the whole story, right? So B and C and D all have different numbers of votes, right, in the Electoral College, but their power ends up being the same. They matter the same. Okay? So that's something we definitely want to pay attention to, right? Especially when we go to our bigger scenario. Okay, so here we go. 51 states. We have their populations in 2010, and then the percent of the population that they have, and then the number of electoral votes and the electoral vote percentages. Okay, and you can see California does not do as well as it should in terms of electoral vote percentage, right, in terms of raw votes. And that's because, again, electoral votes aren't quite allocated proportionately. So California does a little bit poorer than it should in terms of electoral votes, as do the other big states, Texas and New York and Florida. Wisconsin does just a tiny bit better than its population would say in terms of electoral vote percentage. Wyoming does much better. All right, so we want to calculate the bonds-off power indexes for the states, except that is a mess. It's a mess. It's a lot of work, right? Can you picture going through the process we just went through for our small country, doing it with 51 states, okay, or 51 players? It's a lot of work. We can talk about how much work it is. This goes back to that question I asked you about at the beginning, right? So I have 3 pairs of pants and 5 shirts, okay? How many different outfits can I make? 15, right? And you can count it out, right? For my first pair of pants, I got 5 shirts. My second pair of pants, I got 5 shirts. For my third pair of pants, I have 5 shirts. So 5 plus 5 plus 5. Or we can think of it as 3 times 5, right? Okay, that's a process in mathematics that we call the multiplication principle. And so just generally speaking, the multiplication principle says if you have a big procedure that you can break down into a bunch of different steps, if each of the individual steps is independent, then the total number of ways of doing the whole procedure is equal to the product of the ways of doing each of the individual steps. Okay? That's what we call the multiplication principle. So me getting dressed in the morning, I have 2 decisions to make, right? Which pair of pants, which shirt. I have 3 ways of choosing my pants, 5 ways of choosing my shirt, so I have 15 different ways I can get dressed. All right. So here's our question. All right, I want to know how many different total coalitions there are. So there are 51 different states, counting DC, right? And I'm not worried yet about, if we're calculating bonds off power, we have to find the winning coalitions first. But even like the step before that, if I just wanted to list all the possible coalitions, can you see how we can use the multiplication principle to get that? So we have 51 states, right? If we want to build a coalition, one way we can do it is we can decide for each state whether they're going to be in or out. Right? So I want to decide on a coalition. So I have California. They can be in or out. Texas can be in or out. Florida can be in or out. Ohio can be in or out. New York can be in or out. Wisconsin can be in or out. DC can be in or out. Wyoming can be in or out. So the process of building a coalition, I can break it down into 51 different decisions. How many options for each of those? 2. Okay, multiplication principle says I can multiply those. Those are independent choices. So altogether, if I would want to list all the coalitions, winning and losing, there's going to be 2 to the 51st, which is about 2 times 10 to the 15th coalitions. Okay, you can imagine trying to work that out, even on a computer. It's nasty. Okay, good news. There's a computer scientist named Dennis Leach in the UK who's written a program. It's on the web. You can access it. Uses generating functions. It's fantastic. You can feed it the electoral votes and the quota of 270, and in about 15 seconds, it'll spit out the answer. It'll spit out the bonds-off power indexes for you. And that's what I did, and that's how I got the bonds-off power indexes for all our states. Okay, so we can take a look at those. Those are the results. So you can see California, its bonds-off power index is about 11.4. It has 11.4% of the power. So it doesn't quite do as well as its population would insist, but it does better than the electoral vote percentage indicates that it would. Okay, And you kind of work your way down. In Wisconsin, we actually sort of flip a little bit. We don't do quite as well as our population says we should in terms of our power, but it's pretty close. Wyoming still does much better than it should based on its population. Okay? So that answers sort of our first question about power. So we do see that the smaller states generally have more bonds-off power than a proportional distribution of power would dictate. Even when we do this more careful analysis. Right? What about the power of an individual? Okay. Regardless of how we measure it, an individual's power in a state is going to be little tiny. So usually when we talk about the power of an individual, we talk about it relative to other states. So measure power of individuals based on comparing between states. Right. And then within any state, we would expect that our voters will be treated identically. So any individual should, at least in the ideal, have the same amount of power as anybody else. Okay, so if a state has P% of the bonds-off power, then and there are N voters, then a reasonable way to measure power is to just divide by the number of people. Okay, so we can do that. And so if I take California's bonds-off power of 11.36%, if I divide that by the number of people in California, it ends up tiny, okay? As do all these numbers. All right, it's a little hard to get your head around those numbers, and so what we do is we just normalize them to compare them relative to each other. Right, so what I do is I call this number for Wisconsin, we'll call that a 1, and then divide everybody's BPI divided by number of people, divide these quantities by Wisconsin's, and then we get these ratios. And that gives us a nice way of comparing our individual powers between the states. Right? So if we look at that, again, the thing we notice is that the individuals in the smaller states generally do have more bonds-off power than a proportional distribution of power would indicate. Right? So, Wisconsin, if we're 1, we're pretty close to California, Texas, and New York in terms of our relative individual voting power. Wyoming, though, has a lot more power as individuals than its population would suggest. Okay. All right. So that's power. Okay. Now, for the second half of my talk, I want to look at a slightly different measure. Okay, it's very closely related. So we've talked about bonds-off power, and then I also want to talk about how often you matter, or how likely you are to matter in an election. Okay, so if your individual vote as one single person makes a difference in the election, then you matter, right? Bonds-off power measures how often your vote is critical relative to other people's. It's 100% sum game, okay? So what I mean by that is if your power goes up, somebody else's has got to come down because the bonds-off power has to add up to 100%. Now, if we're going to count how likely your vote is to be critical, that is not 100% sum game. Lots of people could potentially be critical in an individual election. All right? And so I want to start talking about the probability of that occurring. Now that's a little tricky distinction to get, and so here's a really simple example, a corporate board. Okay, so pretend there's just a corporate board, it has 5 people on it, and the only way to pass a motion on the corporate board is to have unanimity. So our quota is 5, and we've got 5 people, and they each have to vote, they each have 1 vote to cast. Okay, now in terms of power, how is power distributed? So if I found the bonds-off power index, how would it be split up? Equally, right? So each person should have what percent of the power? 20, right? So each one of them is going to have 1/5 of the power because it's going to be divided up evenly, and so they'll each have 20% of the power. Now, on the other hand, okay, let's think about the probability of an individual, one of these voters mattering in an election. Okay, so how many different coalitions are possible? How many different ways, forget about whether they're winning or losing, how many different ways could they get together and form coalitions? Okay, that there's one that wins, how many are there all together? So if you want to build a coalition, you've got 5 players, Each one of them can decide in or out, in or out, in or out. So if A says in, B says out, C says out, D says out, E says in, then you've got the coalition AE. All right? It's a losing coalition, but it's one of the coalitions. Okay? How many total ways are there to do that? 2 to the 5th, right? That's our multiplication principle in action for us. Each one gets to decide in or out. So altogether there's 32 different coalitions. How many of them win? 1. Okay? So, and in that one winning coalition, who matters? Everybody matters, right? So, assuming that each of those coalitions was equally likely, then your chance of mattering in an election on this corporate board would be 1 out of 32, right? So your likelihood of mattering is 1 in 32. And that's a different measure. You're sort of thinking about things differently than power, right? The 20%, each of them has 20% of the power. Okay, so that's the side I want to look at here in the second half of the talk. All right, so let's count how often an individual's vote matters in the Electoral College. All right, so big idea here. For an individual's vote to matter in a national election, 2 things have to be true. First of all, your state has to matter, right? So if my vote's going to matter, then my state has to matter in the election first. So my state's individual electoral votes have to be critical to the candidate winning. Second thing that has to happen is on an individual level, my vote has to matter. My vote has to be critical in the candidate winning the state. All right, so those 2 things have to happen. All right, doesn't seem very likely. That's okay, because what we're going to do is we're going to calculate it, and then we'll measure things relative between the states. Okay, so let's go back. Let's do this for Utopia. All right, our little town, get a sense of our little country, and get a sense of how this would work. Okay, so let's count how often a voter in state D matters. Okay, remember state D was our little tiny state down here with 3 people in it? Yeah. Okay? So, first of all, state D has to be critical in the Electoral College, right? For one of these individuals to matter, first of all, the state has to matter. Okay? So, these were our winning coalitions. How many times does D critical? 2 times, right? So those 2 times D matters. Okay? So altogether, there's 8 winning coalitions. We listed those before. But then there's also 8 losing coalitions. So every winning coalition really has a corresponding losing coalition. So there's 16 total coalitions. So assuming that all the coalitions are equally likely, okay, so assuming all the states are toss-ups, then D will be critical to the winner 1/8 of the time, right? So that's the likelihood of state D mattering in the Utopia Electoral College. Okay, and now we have to figure out how often an individual matters in that state. Okay, so in our sample election, okay, what did we have here? We had 2 plums and 1 mustard, I think. Yeah. So we had a mustard and 2 plums. Now, which of the voters matter in that election? Does voter 1 matter? No, right? Regardless if whether voter 1 voted for mustard or plum, plum's going to win, right? Okay, how about voter 2? Voter 2 matters, right? If we flip voter 2 to mustard, then mustard would win, right? Voter 3, same thing, right? So, if a voter is going to matter, it'll only happen if the other 2 voters, vote against each other, right? Vote contrary to each other. In other words, if the vote is tied before somebody votes, then their vote matters. Okay. All right. So let's look at the scenarios. All right. So with if these we'll list all the possible scenarios, and we'll see if voter 3 matters. So if voter 1 and voter 2 both vote for mustard, does voter 3 matter? No. If one votes for mustard and the second one votes for plum, yeah, then voter 3 will cast the deciding vote. If we go plum mustard, yep. And if we go plum, no. So, in a again, not knowing anything about how the voters have their preferences, in 2 out of the 4 elections, voter 3 will matter, right? Okay, and that's that's the information we need to determine how likely it is for one of these state D voters to matter in the election, right? So state D is critical in the Electoral College in 1/8 of the elections, and then an individual voter is critical in state D's election, casting its 1 electoral vote in half of the elections. And so how likely is it if we assume independent events? So if we assume that the vote taking place here is independent of what's going on across the nation, then a state D voter matters 1/16 of the time. Okay? And this is a way that you can talk about the individual. It's another way you can sort of think about the power of the individual, right? How often or how likely they are to matter. Okay, so this is the big idea. And now what we want to do is send that to the U.S. Electoral College. Right? So let's look at the big scenario, the big example. All right, so half of our job is actually done for us. We can already count how often a state is critical in the Electoral College. If you go to Dennis Leach's website, he does it. If you plug in the numbers, he spits out the bonds off power, but he also spits out, the program also spits out how often each state is critical, which is great. Because otherwise that'd be really hard to do. Okay, so what we need to do, we have to do the second half. We have to count how often an individual's vote is critical in determining the outcome for the state's electoral votes. All right, and so here's a warning. All right, we're going to have a little bit of technical math. We're going to encounter it. So if you lose the thread, that's okay. There will be like a reinsertion point after this. Okay, so hang on as well as you can, and if you lose it, that's okay. All right, so I'm going to start by making an assumption. It's a simplifying assumption. I'll assume there's an odd number of people in the state. Okay, the even case is similar. You make a slightly different argument, but it will go through in the same way. Okay, so if you have an odd number of people in your state, then an individual's vote's going to matter precisely when the vote's tied, right? Before you go and cast your ballot, right? Okay, so I'll assume, math people, you know, if we want to talk about an odd number, the number of people will be n, and then we can write that as 2m plus 1. So we can think of that plus 1 as the person who hasn't voted, and then the 2m people are the ones who've already voted, and then that last person, that nth person will matter, that plus 1 will matter precisely when the other 2m people split their votes. So we have 2m people. We want to count how often that happens. All right? We have 2m people. M of them are going to vote for mustard, and m of them are going to vote for plum. And you can see there's lots of ways that could happen, right? So it's possible that the first M people could vote for mustard, and then the last M people would vote for plum. Or the first person could vote for mustard, and then the next M people could vote for plum, and then the last M minus 1 people could vote for mustard. There's tons of ways to do it, okay? Math people, can you see how to count that? What is it? 2M choose M is exactly right. So, so you can think of it as we've got 2M spots to fill, and we're just picking M of them. So, and as soon as you pick the M spots that are going to be mustard votes, then the other spots will be filled in with plum votes. Okay? Again, if you don't know what that means, that's okay. So 2M choose M ways to do it. And then there's a formula for that, right? It's 2m factorial over m factorial, m factorial. M is a big number, right? You know, on the order of a million people in your state, right? That would be half the people in your state. So m factorial is enormous, right? This is a nasty number to compute. Okay, so an individual voter is critical to the state outcome in 2m factorial over m factorial elections. All right, we want to find the probability or the likelihood that they matter, so we have to divide that by the total number of ways that the voters can vote. All right, so there's 2m choose m ways of getting a tie. How many total elections are there? How many total ways are there for the 2m people to vote? If we don't put on the restriction that it's a tie, We want to count all the different ways that those 2M people can vote. Can you see how to get that number? All right, we've got 2M people. Each one gets to choose mustard or plum. The first person can choose mustard or plum. The second one can choose mustard or plum. Third one. There's 2M of them. So total number of ways to do it?
2 to the 2M.
2 to the 2M, great. All right. And so if we want to figure out how likely it is that a voter matters, we just look at the quotient of those two, right? So I take 2M factorial over M factorial, divide that by 2 to the 2M, all right? And just flipping and inverting and multiplying, we get this quantity. This is horrible. This is a horrible, horrible number. Okay, if you even if you're running like some computer algebra software, it will overflow it. You can't. It won't give you a good answer. So what saves us is this thing called Stirling's approximation. This is a great thing. So Stirling tells us that when k is a large number, it doesn't even have to be very large, but when k is a large number, k factorial is about the square root of 2 pi times k over e to the kth power. Okay, and here's just a small picture of what it looks like. So here's, this is what the factorial behaves like, and then this is what Stirling's approximation behaves like. These two line up very, very nicely, even when k is relatively small. And when k is big, they're very close to each other, relatively speaking. Okay, so in that horrible expression of our likelihood, we can just substitute for the factorial. So I'll plug 2m in here, and then I'll plug in m here, and then I'll plug in m again. And so I get this expression, right? So there it is with the 2m plugged in on the top, and then I plug in m twice on the bottom, so I end up with something squared. And then the algebra actually is really easy, and tons of stuff cancel, and it reduces down to 1 over the square root of pi times m. Now if you remember, m is about 1/2 of what the number of the people in the state, so we can go back to n by just replacing m with n over 2, and we end up with this. And this is the quantity we're looking for, right? This is the likelihood that your vote matters in your state. Okay, so the likelihood that a voter in a state is critical to that state's outcome is this quantity, where n is the population. Okay, so if you lost the thread there, here's where you can slide back in. Okay? All right, so you can sort of think about this quantity as n goes up. So if as your state's getting bigger and bigger, your likelihood of mattering goes down, right? But what is surprising and important is that it goes down like the inverse of the square root. Okay, which means, so if you picture as n gets big, the square root of n gets big too, but it gets big at a slower rate, right? So 1 over the square root of n gets small, but it gets small relatively slowly. Okay, so if we look, so here's just a quick table counting n, where n is the number of people, and then the chance that the individual matters in the state. We worked it out for 3, right? If there are 3 people, there's you have a 50-50 chance of mattering in the election. And as n gets big, the chances that you matter get small. That fits with our intuition. But look, if we go from 1,000 people to 100,000 people, we go up by a factor of 100 in terms of the number of people, but your chance of mattering only goes down by a factor of 10. And the same thing happens if you go from 10,000 people to 1,000,000 people. The population's going up by a factor of 100, but your chance of mattering only goes down by a factor of 10. Okay? This is called Penrose's square root law. Okay, so what does that, kind of putting this all together, how often does a voter matter? Right, so we count how many times the state is critical in the Electoral College. That's what Leach's website does for us. Then we'll divide by 2 to the 51st, because that's the total number of coalitions, and that gives us the likelihood that a state matters in the Electoral College. And then we calculate the likelihood that a voter in a state is critical to that state's outcome by using that formula that we just came up with, where n is the state's population. And then assuming these events are independent, then we multiply them together, and that'll give us the likelihood that an individual's vote matters in the election. All right, so here we go. Let's look at the numbers. So California is the biggest state, right? Has the most electoral votes. So if we count how many times it's critical in the Electoral College, it's critical a lot, right? And these are the numbers from Leach's website. So we have a lot of gigantic numbers, but then we divide them by 2 to the 51st, and you can see that what this means is that if all coalitions are equally likely, then California's chance of making a difference in the Electoral College is about 23%. Wisconsin's got about a 4% chance of making a difference, and in Montana and Wyoming, the small states have not so much of a chance. Okay, and then we have this quantity, right? This measures the likelihood that an individual's vote makes a difference. And then we multiply these two numbers together, and that gives you the chance that an individual's vote matters. Okay, these are small numbers, but again, we can call Wisconsin a 1, and then carry out the ratios, and then compared to Wisconsin, we can talk about the relative importance, right? So here, things get flipped, right? The big states, the individuals in the big state, have a much higher chance of mattering in an election than the small states, okay? In fact, you can see poor Montana is the one that really loses out. The individuals in Montana have the lowest chance of mattering. You can kind of see why that happens. They've got 3 electoral votes just like Wyoming, so they matter the same amount in the Electoral College. But then, because they have more voters, the chances of an individual mattering is lower. So they're the ones that kind of end up losing out here. That's interesting. So in this analysis, it's the larger states where the individual voters have a greater chance of making a difference, that is being decisive in an election. Okay. All right. So, obviously, there are some limitations to this, right? So I'm going back to the beginning, right, where I made some basic assumptions, right? So I assumed independence throughout, right? So I assumed that whether one state joins a coalition is independent of the behavior of a neighboring state, right? We know that's not necessarily the case, right? If Alabama votes one way for president, it's more likely than not that Mississippi is going to vote the same way. So states don't necessarily vote independently. Right? I also assume that we don't know anything about the preferences of the voters. Right? So I'm assuming that all the states are toss-up states. And we know that's a problem too. Right? Can you think about where the presidential candidates focus their energies? It sounds from this analysis that I'm suggesting they should be focusing their money on California, right? But they don't, right? Because we know California is pretty well determined. Right? If we go back to 2012, for example, this is a list of the top 11 states and their spending on the election, and these numbers represent 99% of all national campaign spending for that election. California's spending in the 2012 election was $320. I'm not missing a decimal point there. Yeah. And of course, the reason is there's no point in spending money in California because we know California always votes Democrat, or at least historically in the last 40 years. Okay, so if you want, you can make some modifications to this analysis to fix things up. All right, so just some suggestions. Like one thing you can do is, if you're going to do the bonds off power calculation, is just do a simple assignment of the safe states. Right, so we know California is going to go to the Democrats. New York is as well. So decide which ones you're going to call the safe states for the Democrats, and then Texas and Alabama and Mississippi, those are going to go for the Republicans. So assign it as far as you're comfortable doing that safe assignment, and then figure out how many electoral votes are already cast for the individuals, and then calculate bonds off power after that. Okay, that's not hard to do, and that will fix up that issue. Another thing you can do is you can find the probabilities that the states will fall to a particular candidate and then weight the coalitions accordingly. So, as I said, assuming that all the states are 50-50, then that allows us to assume that any coalition is just as likely as any other. But really, for example, Wisconsin, I looked this morning, I think Wisconsin, according to the 538 blog, has an 81% chance of going Democrat. So you can say that. Okay, so Wisconsin's chance of being in a coalition for the Democrats is 81%. Florida's, it's 52% chance of going Democratic. And so instead of using 50-50 for those coalitions, you can weight them according to those probabilities and then calculate your bonds-off power that way. So you can get these refinements to the process that'll give you answers that more reflect the realities of a particular election or a particular country. All right, so just some final thoughts. So think again of the analysis that I've done or given you as just a jumping point for some deeper analysis. When you're talking about power in the Electoral College, okay, don't talk about raw votes. Make sure you're talking about power as opposed to the electoral votes, right? The number of electoral votes matters, but it doesn't tell the whole story. And when you're talking about power, make sure you make that distinction between the power of the state and the power of the individual, because those really are different things. And then finally, don't forget to vote. It might make a difference. Thank you.
Okay, we'll open up to questions from the audience, either you or I should kind of rephrase the question again for our YouTube viewers. Andrea.
Well, I have kind of two questions. So my first question is, using one of your two measures of power, is there a way to partition the votes in the Electoral College to give everyone equal power? And if so, which of these two measures would you choose to do that with? Which is sort of better in some sense that I'm leaving up to you to determine?
Wow, that's a great question. I think probably the easiest way would be if you wanted to calculate bonds-off power. The way to do it would be to make the electoral votes truly proportional to population. And if you made them truly proportional to population, that would give you a much better fit than this counting the number of congressmen plus the number of senators. Right? So that would work. I think I can't, don't quote me on this, but I believe that the European Union uses Penrose's square root law. They sort of work backwards from that to determine the number of votes in the EU, and so they try to balance things out that way.
You said you had two questions. I don't know if you wanted to.
My second part was which measure is better.
Okay.
So that was my second part.
Very good. Other questions? There's one in the back.
You mentioned at the very end the probability of the states based on polling going one way or the other. If you look back just over the past few elections, Nate Silver in particular has picked 99 out of 100 states correctly in the last two presidential elections. But if you ask Eric Cantor from his primary a little while ago, which was off by 36%, and he got killed when his pollsters told him he would win the primary, what do you see the accuracy of polling, and if it is decreasing, why?
Wow. Okay.
So the question is about the accuracy of polling, and maybe you can even comment on Nate Silver's methodology in terms of how he actually weighs polls, if you can.
Sure. Yeah. That's a terrific question, and I see Nate has been watching me through the talk, and I have tremendous respect for what he does. He's very data-driven, so his approach is very different from the approach that I've given you. His is statistical, right? So what he says is he looks at the poll data and then runs simulation after simulation after simulation every day, and uses that to predict the winners of elections. Now, so I'm not a statistician, But I think that the biggest problem right now with statistical surveys is non-response bias, getting people to respond. So I don't know about you guys, but I'm getting calls, multiple calls every night asking me to participate in polls, and I just don't answer the phone. And because of that, there is a certain skew to the results that these surveys produce. That people who respond to polls tend to be different in some fundamental ways from people that don't. One of the things that happens is if you believe your candidate, the candidate you prefer, is losing, then you are less likely to participate in polls. So that tends to overestimate the lead that a particular candidate might have. Again, I'm not a statistician, but that's what I perceive as the big problem.
Yeah, and I will just add to that. So Nate Silver really focuses on the track record that a polls organization has, right? And so, because past performance is the best predictor of future performance in these polls, right? Versus at the congressional district level, it's often organizations who have a certain vested interest, I want to say, in portraying these numbers in a certain way, and so often it's hard to get the organizations to really, have polls conducted in those districts.
Yeah, go ahead. I wanted to, just sort of following up, this is a terrible link, but I grabbed it because it was so interesting to me. The New York Times had an article a couple of weeks ago. They had collected data from a survey. I think it was somewhere in the order of 1,000, and the data was there. They had the raw data; it had already been collected, and they passed it off to, I think, 4 well-respected polling organizations, and said, "Here's the data. You guys make your predictions." And so they used various weighting methods to account for demographics, and these 4 organizations got completely different results. So I think one of them had used the data to say that Hillary Clinton was ahead by 4 points. One of them said that Donald Trump was ahead by 1 point, and I think the other 2 were somewhere in between that. So collecting the data is one issue, and then what do you do with the data when you have it? And that was really eye-opening to me. That these are not hack organizations. These were very well-respected polling organizations that got such different results with the same data. It's a real challenge.
Yes, Michelle.
I have a question about population. Fundamental is you're using a population figure.
Yes.
And a population figure you didn't define. Does it include Garrett was in the room, the little one was in the room, or should and then where I'm headed is what happens to the model or to the analysis if you use number of registered voters in the model, because those are really the ones who matter in terms of what happens to Electoral College votes.
Okay, so your question is about,
Yeah.
about
That
my assumption about using populations there.
Well, I know it's
Yep.
tied to, because that's how we figure out how many Electoral College votes are attributed to the state, but then not all those people vote, so there's a...
Yes, absolutely, and I was sort of hoping that I'd be able to slide that one past you guys, but no such luck. Right, so you're absolutely correct. One reason that I chose to use the numbers is for exactly the reason you said. That's to use the populations to get the electoral votes. Right, so when you're calculating the power of an individual, it would be probably more appropriate to divide by the number of registered voters or the number of actual voters in the election. I don't think that makes a huge difference in the Banzhaf power calculation, because that's sort of proportional to the number of individuals in the state, and roughly the states are very similar in terms of the ones that are registered, the proportion of voters who register and the proportion of voters or proportion of people who actually vote. It makes more of a difference in the second analysis because it's not because we're looking at a 1 over square root of n proportion. So it would tend to let me think about that. I think that would tend to favor the larger states a little bit more if we went with that. I use the populations, of course, because that's the easier data to get a hold of.
Thank you.
it was just yesterday when a student in one of my classes asked me, what does this RV and LV, stand for next to these poll numbers? And I said, it's about, either likely voters or registered voters. And, it's polling organizations tend to move as we get closer to election day to a likely voter category, which is most helpful. But it does, make sense to pay attention exactly of who they're actually asking. Other questions? Okay, I think that's good. Let me just make one brief announcement. We do have another center event this week. There will be a student debate that will take place here at 4:15 on Thursday afternoon, where one of our students, I think she is or was here, Rose Hogmeyer, will give students to various student groups, and they will discuss 3 key domestic issues on climate change and energy policy and college affordability and domestic terrorism. So that should be a great event, 4:15 here on Thursday. Let's give it up for Steve Szydlik.